If you are a developer trying to get into AI, you know the landscape of tools can feel, well, like a jungle. It's overwhelming, right? So today, we're going to draw a map, a clear guide to help you navigate the world of machine learning development.
Okay, so let's just start with the biggest question of all, the one that kicks off every single AI project. How do you take an idea, something in your head, and turn it into a real working AI?
You know, the best way to think about this is like you're putting together a really complex puzzle. It's not just one thing. It's a whole bunch of different pieces, languages, frameworks, platforms that all have to snap together just right. So let's start laying out those pieces, one by one.
All right, first things first. Before we even get to the cool tools in our toolkit, we have to understand the job they're actually built to do. And in machine learning, the most fundamental job there is training and selecting models.
So what do we even mean by model training? Honestly, think of it like sending our AI to school. It's the process where we let a model learn from data. And just like any school, the quality of that education depends on a few big things. The curriculum, that's our algorithm. The number of books it reads, that's our data quantity. And how tough the final exam is, that's the complexity we're aiming for.
And this right here is a perfect illustration of a huge trade-off you're always making. On one side, you've got your simple models, like decision trees. They're fast, they don't need a ton of data, and they're pretty light on computer resources. Then, on the other side, you've got the complex giants, like deep learning. These take way longer to train, they are hungry for data, and need a ton of computing power, but the results they can achieve are just incredible.
So what's the whole point of this? What's the end game? We are chasing this thing called generalization performance. It sounds a little jargony, but the idea is actually super simple. How well does our model make predictions on data it has never seen before? That's it. That's the real test of a successful AI.
Now, training these complex models would take forever without some serious hardware. Turns out, GPUs, the same things from the gaming world, were amazing at the kind of math that powers deep learning. Then, Google went and built TPUs, which are custom designed just for this. And now, we're seeing a whole new wave of specialized chips popping up to make things even faster.
Okay, so we get the training part. Now for the next piece of our puzzle, the programming language. And this is a huge decision. It's the foundation that your entire project is going to be built on.
In this space, there are really four main players. Python is, without a doubt, the king of the hill for general-purpose AI. R is the master when it comes to hardcore statistical work. Julia is the speed demon, built for high-performance math. And Scala is what you reach for when you're building massive systems, especially with Apache Spark.
I absolutely love this quote because it nails why Python is so popular. It might not be the absolute #1 best at any single thing, but it's so flexible and has such a massive ecosystem of libraries that it's good enough, and honestly, often great enough, for almost anything you can throw at it in data science.
But hey, let's not forget the others. R was literally created by statisticians for statisticians, and its power for data visualization is legendary. Julia was engineered from the ground up for one thing: pure, unadulterated speed in numerical computing. And Scala, which runs on the Java platform, is the go-to when you need to plug into huge data processing systems like Spark.
Speaking of speed, let's just pause on Julia for a second. I want you to look at this number, 10x. Just 10 times? What could that possibly mean?
Well, here it is. The Federal Reserve Bank of New York, when modeling the entire U.S. economy, switched to Julia and found it was a full 10 times faster than what they were using before. I mean, that's not just a small improvement, that is a complete game changer.
So, we've got our process, we've got our language. Now, let's open up the toolbox and look at the actual tools, the frameworks, platforms, and environments that data scientists are using every single day.
If languages are like the raw materials, then frameworks are your power tools. They give you all these pre-built, optimized components so you're not stuck reinventing the wheel every single time. They just let you build and train models way faster and more efficiently.
And here are the heavy hitters. You've got scikit-learn, which is like the Swiss Army knife for all-purpose machine learning. Then there's TensorFlow from Google, an absolute powerhouse for deep learning. Keras, also from Google, is like a super friendly layer on top of TensorFlow. And then you have PyTorch from Meta, which is famous for its flexibility and is a huge favorite in the research world.
So what happens when your data gets too big for just one computer? That's when you turn to Apache Spark. It's a framework designed from the ground up to handle massive data sets spread across a whole cluster of machines. It's pretty much the standard for big data work these days.
And you can't really talk about the ML world without mentioning Kaggle.
It got its start as this cool platform for machine learning competitions, but it has grown into a whole ecosystem. Now Google owns it, and it's this amazing place to find data sets, share code, and even grab pre-trained models to get a head start on your projects.
Now, we mentioned notebooks, and this is such a key concept to grasp. Think of a notebook as a data scientist's lab or their workbench. It's not where you write the final polished application. No, it's for playing around, for exploring ideas, for visualizing data, and for sharing your research with other people in a way they can actually follow and reproduce. And the two biggest names you'll hear are Jupyter and Google Colab. Jupyter is the open source standard you can run right on your own laptop. Google Colab takes that exact same experience, puts it in the cloud for free, and this is the killer feature, gives you free access to powerful GPUs. That's just amazing for deep learning experiments.
Okay, so we've looked at all the different pieces of the puzzle. The process, the languages, the frameworks, the tools. Let's try and put it all together now, and while we're at it, bust a very common myth.
With this gigantic, sprawling ecosystem of tools, it's only natural that people are looking for that one single solution that does everything. But as the source material asks, how can there possibly be one platform to rule them all?
Well, a simple answer is there can't be, and here's why. What a data scientist needs to explore data is totally different from what a data engineer needs to build reliable pipelines. The messy, experimental code you use to build a model is not the same as the rock-solid code that serves that model to millions of users. And AI runs everywhere now, on your phone, on the server, in the cloud. The reality for smart companies is a mix-and-match approach.
And that really brings us to our final thought here. The world of AI development is moving at lightning speed. New tools are born, old ones evolve. So the big question for all of us is this: which of these tools, or maybe just maybe one that hasn't even been invented yet, is going to define the next generation of artificial intelligence? The only thing we know for sure is that this puzzle is just going to keep getting more interesting. Thanks for joining this explainer.